Hi, this video is going to discuss kinetic energy. By the end of this, students will be able to identify the components of kinetic energy and how work and kinetic energy are related. Let's start with what kinetic actually means. Kinetic, by definition, according to Merriam-Webster, is of or relating to the motion of material bodies and the forces and energy associated therewith. Fancy way of saying it deals with things moving. So in other words, kinetic energy is energy due to an object's motion. In other words, if an object isn't moving, then it doesn't have any kinetic energy. So the equation for kinetic energy is 1/2 mv squared, where Ke stands for kinetic energy measured in joules, m stands for mass measured in kilograms, and v stands for velocity measured in meters per second. In case you didn't notice, kinetic energy and work have the same units, which are joules, which we just use as J. This isn't a coincidence. Doing work changes an object's energy. It's going to be a revolving theme in this unit. So some examples of this would be like car's brakes and a car's engine. Brakes do work to slow a car down, reduce its kinetic energy. An engine provides an increase in kinetic energy, so it does work to make the car go faster. So this equation says delta Ke equals W, and this literally means the change in kinetic energy is equal to the work done. So in other words, doing work means that the kinetic energy will change. So you could do work to speed up things and slow things down, just like the brakes and the engine example in the previous slide. The first challenge question says a car is traveling at some speed v with some amount of kinetic energy. If the car's velocity is doubled so that it's twice as much, what happens to the kinetic energy of the car? If you said 4 times the kinetic energy, then good job, because that's correct. V is squared in the equation, so doubling the velocity means you'd quadruple the kinetic energy. 2 squared is 4. Second question says a car of mass m is traveling at some speed v with some amount of kinetic energy. If the car's mass is doubled to twice as much, what happens to the kinetic energy of the car? If you're thinking it's got to be 4 times the kinetic energy again, then you're missing something. That's not right. It's actually twice the kinetic energy because in the equation for kinetic energy, m isn't squared. It's just 1/2 m by itself, v squared. So if you double m, you'll double the kinetic energy. That's it. Thanks for watching. As always, make sure you answer the questions in Schoology and bring your notes with you to class next time. Thanks for watching.